Welcome to clickmyproject.com. Our project title is Optimal Partial Relaying for Energy Harvesting Wireless Networks. Abstract. In this paper, we assess the benefit of using partial relaying in energy harvesting networks. We consider a system composed of a source, a relay, and a destination. Each of the source and the relay has energy harvesting capability and generate its own traffic. The source is helped by the relay through a partial relaying network level cooperation protocol. The relay regulates the arrival from the source by accepting only a proportion of the successfully received packets at the relay. The relaying parameter, which determines the proportion of packets to be accepted, is selected based on the parameters of the network to ensure the stability of the source and the relay data queues. In this work, we provide an exact categorization of the stability region of the network. We derive the optimal value of the relaying parameter to maximize the stable throughput of the source for a given data arrival rate to the relay. Also, we compare the stability region of the proposed strategy with partial relaying to the stability region of simple transmission strategies. Finally, we consider the problem of network relay optimization, in which we optimize over the value of the relaying parameter for a given pair of data arrival rates for the source and the relay. Let us see the flow of our project. First, network is formed. From that, we have to consider our energy harvesting computation from calculating the energy model in our project. Then we have to select the relay node. It is selected depending upon the routing table information, which is generated by PRNC protocol. Our protocol generates the routing table information. According to that routing table information, there is routing identified. It analyzes the stability based upon the energy queue as well as data queue. In energy queue, MM1 technique we use, and data queue MG1 technique is used. Finally, data transmission is done, then evaluation is done. Let us see the output of our project. First, open the VMware workstation. Then we have to open our net terminal window. In the terminal window, open the code directory, that is cd space our folder. In that, for running our TCL file, we have to type ns main.tcl. When running this, it will produce a NAM file as well as trace file. For running these two files are our output files. NAM is nothing but our network animation file, and the trace is that our energy consideration and routing process, what all the process done in our project is traced by that trace file. So now time slot. In our project, we consider the energy harvesting and as well as the time slot using TDMA scheduling process. So now our NAM trace will open, and in that we have to click in this play power button, which works. So in our network consists of 50 nodes, which is placed dynamically. When we increment this speed, it will start the process. In our project, source and destination also deployed dynamically. So the node 6 is act as a source and 22 is act as a destination. The process is done. If the process is in distance, there is a minimum range, it will goes directly to the destination node. If the process, when we running this process again, it will dynamically generated, so source and destination is deployed in various places. So this is our time slot and our energy efficiency at what time. So timing based all the information and the transmission is done. Now source and destination is in another place. So for our running our graph, there is a simulation from that trace file. We have to generate our graph. For that, type xgraph space delay.xg for calculating the delay. We produce our xg graph. That is our performance of our delay. For throughput, type delay.xg tho.xc. This is our trace file. We have to extract this from our trace file, that is .tr extension. This is stored in our code.